Question 6. Water is leaking out two containers. The water started leaking out the containers at the same time. Straight line P shows the amount of water in container P and Q in Q. Question 1. Work out the gradient of line P. Well, I always find the easiest way of these questions is to look at where it starts from. Look at where it ends. So it's the movement downwards there and then across. So this movement is a negative movement and this is a positive movement. So this is 6A. So the gradient is the change in up and down. Now because it's the change downwards, then it's negative 14. So it's moved 14 down and then it's gone 40 seconds across. So if you do minus 14 divided by 40, that'll then give you 0.35. So we're on that one then done. We've then probably got another question I would expect. One container will become empty first, so this is part B, part 1. Which container, you must explain your answer. Which container is going to become empty first is this one, so P. So P will become empty first, as there is no water left after 40 seconds. Part 2. How much water is then left in the other container at that time? So you go up and you go across and you'd see that it was 1, 2, 3, 4, 5. So it'll be 1, 2, 3, 4, 5 up here. So then you would see 2 litres. So 2 litres will be left over. Question 7. I found this question quite interesting because a lot of students that I saw do this actually then try to complete and drew out the pie chart when it actually just asks you to complete the table. So what you've got to look for is you would normally, if I just move this slightly further across so we can fit everything in, you'd normally create an angle column. And the thing you know about the angle is that it will go to 360. So if the angles will go to 360, you also have here that 100 degrees is already year 7. So how do you go from 900 to 360? Well, what can you do? What can you times it by, or what can you divide it by? I think I'll look at it this time in terms of what you can divide it by. So if I do 900 divided by 360, that will tell me what my converter is. I call it a converter, it's probably not the right term, but you get the idea. And that's 2.5. So if I divide each of these numbers here by 2.5, so 225 divided by 2.5, that gives me 90 there. And then I've got 125 divided by 2.5, it's 50. Now I can do it either way, it doesn't really matter, because we're going to have to go backwards anyway, but that's that point. And just double checking here, so I've got then 162 £1.50, divide that by 2.5 again, and that's 65. So I can then fill in this gap, because if I add my 100, my 90, my 50, my 65, that gives me 305. So that tells me this here must be 55 to make it up to 360. So then I'm going to go backwards on myself. So then if I times it now instead of dividing, 55 times 2.5, then that gives me £137.50. And then if I do the 100 times 2.5 as well, that gives me £250. And this is where you check, because if you add up the 250 to the 225 to the £137.50 to the 125 to the 162.50, then you get 900. So therefore, it's more than likely you've got that question right then. Question 8, cumulative frequency question here. Find an estimate for the median heights. So what are we going to do here with this? How are we going to work that out? Well, median is the middle of your cumulative frequency. So here we've got jumps up. Now each jump is going to be worth 2. So it jumps up 2, 4, 6 and 8. So our top value, we have 88 pieces of information. So 88 pieces of information means that our median then is going to be between about halfway from this point. So if we get 88 and add 1 and half it, that'll give us 44.5. So if we go at 44.5, so 44.5 is there. So if we then go across and hit the line and then come down, now that then is 1, 2, 3 squares into 80. So our part A answer will be 83. We're then going to work out an estimate for the interquartile range. So again, if you've got 44, you can just half that value. It's 22.25, but to be honest with you, 22 will do the job. So you go at 22 and you've got to be absolutely accurate on this. And go up. And do the same thing here at 66. And again go down. So the interquartile range then is 87 take off 77. Now I then get 10. Actually the answer is 9. So I think they give you a fair range here. A1 for answers in the range of 8 to 10. So as long as you're drawing yourself these lines on here and showing that you know what you're doing, then I think you'll be okay in terms of getting the full marks there. We'll see if you can get 9 and be more accurate than I am. Find this with the number of hollyhock plants that are taller than 90 centimetres. So we go up to 90. So 90 and go across. That'll be 2 squares there. So if we drop 2 squares down from that, each jump remember being 2, then that'll give us 76. So 76 is a value. What's it saying here? Estimate the number of hollyhocks plants taller than 90. So again, if I just go up to 90 again and just make sure I'm going across and get this around about right. I think in fairness you could probably make a case for it being one more step higher. So if you look at how accurate my drawing is, it's probably nearer to 80 than I'm giving it credit for. So let's go for 78 instead. Now 78 isn't your answer, because what you've then got is 88 values and 78 and above are greater than. So there's 88 values in total. You take 78 off because it's saying more than 90, so it's wanting this area here. So in effect it's looking for this part here, which gives you then 10 as your answer. Question 9. A newspaper probability any customer buys a newspaper is 0.6. 0.6 there. The probability they don't then is 0.4, and the probability that a customer buys a magazine is 0.3. So that'll be 0.7, and they're not affected by each other. So we go through there, and we've got those. It then says work out the probability that the customer will buy either a newspaper or a magazine, but not both. So we're looking then for part B, the probability of a newspaper and then not a magazine, because that's one route, newspaper and then not magazine, and also the probability of not a newspaper and then a magazine. So probability of a newspaper is 0.6, and then we times in that then by not a magazine, which is 0.7. So 0.6 times 0.7 is 0.42. And also the probability here of not a newspaper, which is 0.4, and then does buy a magazine, which is 0.12. And then we add those two together, which then gives us 0.54. Question 10. Daniela works in a shop. Served 50 customers in the morning, 75 customers in the afternoon. So I think as I'm reading this, I feel like I should be writing certain things down. So 50 in the morning and 75 in the afternoon. The mean time to serve all 50 customers in the morning, so this connection here is, that's the mean there. The mean time to serve all 125 customers, so we've got an all one here, is 50.2 seconds. Work out the mean time to serve 75 customers in the afternoon, so we've got to find out what that is. So the first thing we can do is times these together, because that will give us the total seconds overall that it took and the total seconds in the morning. So 50 times 48.7, so there's 2,435 seconds there. In total, our entire day has taken 6,275 seconds. So if we take one off the other, that will give us how many seconds the afternoon took her, which is 3,840. So 3,840 can come in here, and then you divide it by 75, because there's 75 customers. So then that gives you 51.2 seconds, and just underline that a few times to highlight that's what you're looking for. We've then got a box plot that we're asked to draw for part B. Least time was 18, so I'll draw this, well, I'll attempt with the straight line tool, but let's see how this goes. So it's not that at all, let's try that again. 18 there, so 18, I'll land at 18. Again, you will do this a hell of a lot faster than I am. The next one then is the greatest time was 96, so each square is worth 2. So if I drop 2 squares back from there, then I'm at 96. We've then got the median time was 56 seconds. So 56 seconds, slightly larger line, because this is half the middle of your box. We've then got the lower quartile was 32 seconds. And then we've got the upper quartile was 72 seconds. We then connect the box up to create the box, and then we join the greatest and lowest values there.